So we have some questions with us that we'll be solving today, and we'll be doing the concepts from week 3 and 4 alongside these questions. We'll be doing the concepts while doing the questions. If anyone has any particular doubt from any particular topic from week 3 and 4, you can ask them
Ma'am, can you give
in
guidelines about
concepts.
the quiz one, ma'am?
Sorry, what?
Can you give the guidelines about quiz one?
Guidelines as in,
Like, what are the things we should carry?
I'm not sure about that. You can read it from uh, the things that you've been provided, right? It must be
Yeah,
mentioned
ma'am.
somewhere.
No, I have mailed the IIT support team, but they didn't reply. So I'm just asking you.
Okay, so I'll ask them to get back to you, or I'll connect you with someone else who can
Okay, ma'am.
guide you on this. Is that okay?
Thank you, ma'am.
Okay. Just remind me about this at towards the end of this session.
Okay, ma'am.
Okay. So let's do some questions from week 3 and 4. This is the first question that we have to do. Uh, give this question a try and then we'll do it. Or maybe we should do it here only without further ado. Here it says that you have so alpha is a number that satisfies this equation. That means alpha is a number such that alpha square is equals to 5 alpha minus 3, and beta is another number such that beta square is equals to 5 beta minus 3. So this simply means that alpha and beta are roots of x square minus 5x plus 3 equals 0. Okay? I have to find the value of, so to find is alpha by beta plus beta by alpha, which is the same as, so you have to find alpha square plus beta square by alpha beta. Now, when you have two roots of a quadratic equation, you know that the product of these roots, let's say that your quadratic equation is this, right? So alpha beta is the product of roots is my c by a, right? So this should be c by a, where this is a is 1, b is minus 5, and c is 3. So c by a becomes 3. So the product of alpha beta is given to you here, right? Directly given to you in the question. That alpha beta should be 3. What's not given is alpha square plus beta square. This is not given because we're not familiar with the sum of squares of two roots. We're familiar with the sum of two roots, right? So we know this. This should be equal to, looking at this equation, what should be alpha plus beta?
Can't we solve this alpha and beta both quadratic equation to find alpha and beta? Alpha square
You
minus
can do
5
that.
alpha.
You can try to find the, you can do that way too. You can find both the roots and then find this ratio and this ratio and then add both of them. That works too.
Ma'am,
That's
how
fine.
how is it how you wrote that alpha and beta are roots of this quadratic equation?
Okay, alpha and beta, basically alpha is a number such that when that number is squared, it's equal to 5 times that number minus 3, right? So alpha is basically the root of, what would you get if you put alpha here? You'll get alpha square minus 5 alpha plus 3 equals 0, right? That means alpha square is equal to 5 alpha minus 3, and that's what's
Oh, okay, okay,
exactly given to you, right? The
okay.
alpha is,
Alpha is one of the root and
beta is the other
beta
one.
is also okay.
Yeah.
Okay.
One way is to find the roots of this quadratic equation and then find this expression. The other way is, you know what alpha beta is, you have to find this thing. You know what alpha plus beta is. Alpha plus beta should be minus d by a, right? So it should be 5 by 1. So it's 5. And you have to find alpha square plus beta square. So alpha square plus beta square, and we know alpha square plus beta square plus 2 alpha beta is the same as alpha plus beta whole squared, right? And you have the value, you have this value, you have this value too. So you can find alpha square plus beta square, right? This would mean that your alpha square plus beta square should be equal to alpha plus beta squared minus 2 alpha beta, right? So this value is 5 square. It's given to us, and 2 times alpha beta, which is 3. So this becomes 25 minus 6, which is 19, right? And you have to find, so alpha square plus beta square by alpha beta should be equal to 19, and alpha beta is 3. So it should be 19 by 3. So it's here, this option. Is this question clear to everyone?
Yes, ma'am.
Then let's do this question.
Ma'am, I had a question.
Yeah.
Are we just going to do sums today, or are we also going to revise the theory?
Theory is because, okay, when you do questions, the theory gets revised automatically, right? Because you're doing these things. The sum of roots is this, sum of
In this
product
question,
of roots is this. Yes.
yeah, in this question, the equation are in alpha and beta square. So how did we form x square minus 5x plus 3? Because this would be two different equation that is comprising of alpha square minus 5 alpha plus 3, and same with beta. So I'm confused with this equation, the second part.
You're saying this is given to you 5 alpha minus, what was it?
Minus 3, same with beta.
Then same was with beta. That
Right.
means, and when you write this thing, when you have this thing, x square equals 5x minus 3. Now this is basically an equation. This is a number, alpha is a number, right? Beta is a number that's given to you. X is a variable, right? That means x square is equal to 5x minus 3. And we know if you have an equation like this, x square, let's say you have x square is equal to x, then there'd be two values that will satisfy this equation because it's a quadratic equation. Same way.
Okay, like that way, two
Yeah.
values of equation. Okay, satisfying the equation. Okay.
The two values here are alpha and beta. So if alpha and beta are the roots of this equation,
It
that
should
means,
satisfy the,
yeah.
okay, like that. Okay.
And about discussing the theory part, the theory actually gets revised with the questions, because each time there's a different question, we have a different theory for it. So we'll not be discussing. I can discuss if there's anything particular you want me to discuss, we can do that. We can discuss the quadratic, that whole thing there. If this is your quadratic, this is the graph of your quadratic function, then what's the vertex, what's the axis of symmetry, and all of that. We can discuss that in one, like in one figure. We can do that. Other than that, I don't think there's anything to discuss.
Can you show the next question?
Whenever a question comes on the intersection, like say a polynomial is meeting with some, say, quadratic, then we have to equate the two equation to find a value, common value.
It basically means if you have px is one polynomial, p1x, and p2x is another polynomial. So if you want to find the point of intersection, means if you have y is equals to this and y equals to this. So this is basically xy. So if this is the graph of p2x, that means every point that's on this line, xy coordinates, is on this. And if that, let's say x naught, y naught is on this curve, that means it's here. That's when it's going to satisfy this. And if x naught, y naught is also here on this curve, that means it will lie on this curve. So There could be more than one point of intersection, obviously. It depends on what you get while you equate these two things, P1x equals to P2x. If this is a quadratic thing that you get, then you'll have 2 points of intersection. Otherwise,
We just have to equate the both equation.
yeah, you just have to equate to find the point of intersection. Because the y coordinate of both of these should be same, right? At the point of intersection. That's why we equate things.
Yeah, hello. Actually, I solved the previous question different way. What I did, alpha square, alpha by beta plus beta by alpha. I just equated it with alpha square plus beta square by alpha beta, and then just put the value there. The answer is same, 19 by 3.
So you did it the same way, right? Where you have done it this way.
Yeah, by alpha beta, yeah. And then after I just put the value. 5 alpha minus 3 plus 5 beta minus 3.
Okay, so you're saying that you put beta square equals this thing and
Yeah. Alpha squared this thing. And then after I took the common 5 alpha plus beta minus 6. And then after I put the value of alpha beta. Yeah, I solved this.
okay, that
this way.
works too. That's fine. You can just club these two together, right?
Yeah.
That works.
Thank you.
The next one is this. So when you have something like this, 2 and we have variable here and we say that this is 1, then this should be 0.
Covered 0.
This is not something that we've covered in first 3 or 4 weeks.
We can
So
equate 1 to 2 to 0 and solve that.
It will be
What?
1, 5, and minus 10.
This one.
Yeah, we
So
can do
option
that, but
A, C, and D.
okay. So this is
If you
the
can explain this.
important thing to notice here is, yeah, I'm going to do that. If you have something like this, let's say you have 2 and to the power x equals to 1, or let's say 2 to the power tx, there is a function equals to 1. Now this means when you have 2 raised to some power equals 1, then this should imply that your x is 0. That means that power
Yes.
should be 0, right?
Hmm.
That's the only possibility you have. So if you want this thing, 2 to the power tx to be equal to 1, this should mean that your tx is 0.
X is 0.
And as
So you,
1 can be written as 2 to the power 0.
right. We're not getting into the details of exponential functions because we've not done that. So for now, you only have to keep in mind that if your 2 to the power x is 1, and we're going to do this in later weeks, where we'll see why if 2 to the power x is 1, then why does it imply that x should be 0? And it's if and only if, by the way. So the only possible solution is x equals to 0. Okay.
Is this the only solution that is possible?
Yeah, that's the only possible solution. If you look at the graph of, I
Okay.
didn't want to touch this topic. So if you look at the graph, it's like this. So the only point here, that means if you want 2 to the power x equals to 1, that means you want your y to be 1, and your y is 1 here. So the only possibility is x being 0. That's it. That's the only time you will see
An
this
exponential
curve
part, right?
intersecting. What?
It comes in exponential.
Yeah, it comes in the week, in week, I don't remember the
Week
week
5
number.
only it is there.
Yeah, it's a part of that week. But for now, you only have to remember that if your 2 to the power x is 1, or for that matter, any number to the power, if you have any number, and that is raised to power x, and this is given to be 1, then this should mean that your x is 0. That's the only possibility.
Yes.
So if you have 2 raised to some power and that thing is equals to 1, that means from here, that function should be 0, right? That means x minus 1, x square plus 5x minus 50 should be equal to 0. Now you just have to find the roots of this equation, this polynomial. So one root is this is already being factorized as a linear factor. So this will give you
1.
x equals to 1. And this is going to give you two roots, which you'll have to find. So this
We can
product should
factorize
be
it
minus
minus
50
10,
and
5.
should be 5. So it should be 10
10
minus
minus
5.
5.
And that gives you minus, no, this gives you minus 10 plus 5.
Minus
And
10
this
and
gives
5,
you,
if we take then
but the roots
minus
will be
50.
5 and minus 10 only.
Hmm.
This will be x minus 10 and x. This is x minus 10 and x plus 5.
Ma'am, x plus 10, I think, and
X
x
plus
minus
10
5.
and
Because 5x is 10x minus 5x. And 10 into minus 5 is
x
minus
plus
50.
10 and x minus.
And 5.
This gives you x and x minus 10 from here.
No, ma'am, it should be 10x minus 5x.
Some 10x would be positive.
Yes, ma'am. 10x minus
Yeah,
5.
it should
Then
be
it
10x minus 5.
You have minus 5x here. So this will be minus 5.
yeah.
It's x minus 10 and 5.
Yeah.
So one root is 1. The other two roots. You can also use the quadratic formula. You don't have to do it by
Yes.
writing them every time. So these are the roots 1 minus 10 and 5. So that
A,
means
C, and D.
1 minus 10 and 5. It's okay with everyone?
Yes, ma'am.
Yes, ma'am.
Is it fine with others too? Okay. Then the next question is this one, where you have a polynomial px with another polynomial qx. You're dividing it with a polynomial qx. That means you write px equals using this is called division. By division algorithm, you don't have to remember the name, division algorithm. So you have qx and we get the quotient as hx. That means you should have an hx here and rx as the remainder. Oh, they've already written it here. The minimum degree of Rx can be, now this is your remainder and we've already done this, that either an important part here is to note here is that either your degree of Rx, the remainder, the degree of this thing should be less than the degree of this.
Yes.
Your divisor.
Okay, ma'am.
Strictly less than this degree of Qx, or you should have degree of you should have Rx equals to 0, in which case the degree of Rx is not defined.
Okay, ma'am.
So this should be it. Now that they are asking about the minimum degree of Rx. So the minimum degree of Rx can
Could be 0.
because there's nothing given about Px, Qx in any of it, right? So the maximum degree is when you have something like this, let's say x is greater than a and less than b. That means the maximum value x can take is this, right?
Yes,
But actually
ma'am.
not even this, in this case b minus
1.
1
1.
if these are integers.
Yes.
Only if x is integer. So if x is integer, then the minimum value your x can take is minimum value of x should be, so the minimum value should be a plus 1, because this is an integer, and if a and b are also integers. So if a, b, and x all are integers, let's say x is between 5 and 7 or 5 and 10, then the minimum value, because it's given that x is an integer and it has to be greater than 5, that means the minimum value x can take is 6, right? Because it's an integer. And the maximum value 6 can take is 9. So if you write it in general, it will become minimum value of x should be a plus 1, and maximum value of x should be b minus 1, right? But that only happens when all of these three things are integers. Now, let's say if you have a, this is not needed, but I'm still discussing it. If you have x between a and b, and these are, let's say these are all real numbers, a, b, and x all are real numbers, then what can you say about the minimum value your x can take, or the maximum value your x can take?
We cannot say anything because these are dense.
Yeah, let's not get into dense and all. It simply just means if you have 5 here, let's say you have 5 here, 10 here, and you say that your x cannot be 10, but it's lesser than 10. So you can't find the maximum number, right? Because 9 after, between 9 and 10, there is something. There'll be 9.1, then you'll have 9.2, 9 after 9.9, you'll have 9.91, 9.92. It's basically not possible for you to find the maximum value your x can take. But because they are given to be integers, so you can find. And we already know that your the entire point here is that your degree of Rx is greater than equals to 0, and this is less than degree of Qx, right? So the maximum degree Rx can take is
Degree of
maximum
qx minus 1.
degree from what we've discussed so far, because the degree of Rx is an integer. In particular, it's a natural number, but it's also an integer, right? So same applies for natural numbers too. So because this is an integer, this is also an integer, and this is also an integer, so you can apply the same thing here. And you can say that the maximum degree of Rx possible should be degree of Qx minus degree minus 1. And the minimum degree of Rx here should be now it should be 0. Why not 0 plus 1 here? Because your degree of Rx can be 0. Here we have greater than equals to. Here we had strictly greater than, right? So here
Yes,
we
ma'am.
had x strictly greater than a. That's why the minimum value x can take is a plus 1. Here we have degree of Rx greater than equals to 0. That's why it can also take the value 0. So the minimum degree of Rx should be 0. And the maximum degree should be this.
Ma'am, but if the divisor and the dividend both are constant polynomial, in that case, but the in that case the quotient will also be constant, right?
Yeah.
Then in that case, the degree of the quotient is 0. We cannot say that degree of remainder will be minus 1, right? So the
Yeah, it
condition
can't be
has to
because
be,
this,
yes, ma'am. Condition should be both of them has to be non-constant polynomial.
just 1 second. Or maybe I can just incorporate the other case too here. One case is when you have both of them constant or both of them of the
Yes,
same
ma'am.
degree, when your degree of Rx will be 0. So if you have 0 there, then
Ma'am, let's say 7 and 2. One
if we
polynomial
can
is
talk about,
7.
yeah, I understood that point. If you can talk about the degree of Rx, and if we are assuming that the degree of Rx exists, that means your remainder is not 0. And we can just simply say it's the minimum of degree of Qx minus 1 and 0, or maximum actually. can take this thing here. So this just fixes everything. Is that okay? Instead of avoiding the case where you are taking the degree of, okay, we have this thing px, qx, and we have hx here and rx here. So instead of avoiding the case where your degree of this and degree of this is both 1, what we're doing is we are incorporating this case in this formula now. Now we don't need to remove the condition where
Ma'am,
or
Q
remove
of
the
X is
possibility.
quotient, right?
No, it's the divisor.
Okay, okay.
This is the
If that
divisor. This is
is
the
okay,
quotient.
ma'am. If that is the divisor, then the degree of R of X is equal to the degree of Q of X, isn't it? Let's
No,
consider 7 and 2. In that case, we are getting remainder as 1. So all of them, I mean, the 7 is of degree 0 and 2 is of degree 0 and 1 is also of degree 0.
but this formula is valid there, right? Your degree
Uh,
of remainder,
yes, ma'am. But the degree of remainder is becoming 1 here. So degree of Q of X is 1, right? 1
if,
minus 1 is
if
0.
your remainder is a constant, how is the degree 1? The degree is 0, right?
That is 0. And also our quotient is
I
also
think
0,
you
right?
are getting confused with the degree and the absolute integer. Here, madam means the degree. She is talking about degree.
Yeah, I know, like 7 and 2 both are 0 degree. A remainder
Okay,
is
if you'll
1.
have
That is
7,
also 0 degree.
you'll have 2 here. You'll have
Yes, ma'am.
remainder 1. We
Hmm.
are saying that the degree of your remainder should be
Hmm.
equal to maximum of the maximum degree your Rx can have is we're saying degree of Qx minus 1. So your degree of Qx minus 1 will give you minus 1, right?
Yes, ma'am.
And this is going to give you 0. So we have to take the maximum of these two, that will give you 0, which is 2, right?
Oh, yes,
Degree
yes,
of your
yes, ma'am.
remainder is
Got it.
0.
Okay, ma'am.
Okay. Okay, so this is it. And what was our question? It's done, right? The question we're done with this question. Does anyone have any doubt in this thing that we've discussed so far?
Ma'am, I have one more doubt. Can you go back to question?
Yeah.
Yes, ma'am. So we can have 0 as the remainder, right? In that case, our degree is undefined.
So we're assuming the degree to be defined. And they're talking about the minimum possible. When you talk about when you have everything variable, when you have this variable, we don't know any value here. Then
Yes.
obviously one of the possibilities your Rx can be 0. But they're talking that in that case degree would not be defined. That's right. But they're talking
Yes, ma'am.
about minimum degree. So out of the degrees that are possible for remainder, what's the minimum degree? That's the question, right?
So here the
Okay.
It
minimum
still
degree would be
holds,
0.
right? It will be 0.
Right.
Ma'am, could you please?
If it's a maximum, then the divisor minus 1 degree. That
Yeah.
term
Then
would
it's
satisfy.
this one.
Yeah.
Can we move to the next question if this one's done?
Yeah.
Yes.
This is the next question. And so it's you've been given one line, not actually a line, you have been given one curve, cubic curve, and you have to find the value of n. This is n here. You have to find this value. To minimize the sum of squared errors. So your sum of squared errors is, let's just find the sum of squared errors first. So it's basically, if I'll make one more column here, y cap, and so y cap, what is y cap here? Y cap is basically y cap of x. Let's define it as y cap of x, or So your y cap of x is
Standard
just
approach
this,
will
right?
do, but just trying to brainstorm with this solution, can't we differentiate the effects to find the minimum point and then put x and y respectively?
Okay, you're saying
I know the solution may sound bizarre to people, but since it's asking for the minimum, so can we do that? Just asking.
so that SSE will be, you have to minimize the SSE. For that, you'll at least have to find SSE. You can't use the derivative of this function directly, right?
Okay.
First, you'll have to find the SSE, and then we can proceed further. So your SSE is basically your y cap x is when you substitute x equals to these values in this function, right? So if this is your function, this is the data that has been collected, and this is, so someone has tried to fit a line in that data, not a line, actually a cubic curve. And so your y cap x is basically, they shouldn't have written fx here because they've already used fx here. So let's call this one gx. So your y cap x is just gx. That means if you substitute minus, your y cap of -3 should be equal to -3 substituted in this equation. Is everyone clear with how we find the sum of squared errors, or should we do that in detail first?
Yes.
So what you do here is, first you find y cap x. So you'll first substitute -3 here. So at x equals to -3, your g of x is -3 cubed, which is -27, plus 3 times 9, which is 27, plus n, right? So this is going to give you just n. At x equals to -2, your gx is going to be -2 cubed, so -8, plus 12, plus n. So this is n plus 4. At x equals to -1, gx is going to be -1 plus 3 plus n. So this is going to be n plus 2.
Ma'am, my answer -2 is coming for n.
Okay, let's see.
I guess 0 will be the answer.
-1, 3, and n, right? And at 0, you will have n, right? And then what you do, for sum of squared errors, you do summation of y cap x i's, or I should say gx i's simply. Summation of gx i's, where x i's are these. This is x1, let's say this is x1, this is x2, this is x3, this is x4. And then y i's, I varying from 1 to 4 in this case. So let's consider this thing as x1, x2, x3, and x4. These values of x as x1, x2, x3, x4. And these values of gx. Here, these values of gx as gx. So this will be gxi, right? And consider these as y1, y2, y3, y4. Is this okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This will be it. So your sum of squared errors becomes one second. So you'll have, first you'll have n, and then you will subtract y1 from it, which is -2. So that means you'll have minus of -2, so +2 here, squared. Then you have n plus 4. and you subtract this thing 2 from it. So you'll get again n plus 2. Then you will have n plus 2 here, and you will subtract this by 3 from it, which is 0. And finally, you will have to subtract minus 2. So this is n, and you will subtract minus 2 from it. So you'll get n plus 2. So this is simply n plus 2 squared. And you have to minimize this thing, right? So you will have 4n plus 2 squared. Now you don't even have to use the derivatives and all here in this particular case. You can avoid the derivative approach and still find the minimum of this function of n. Can someone suggest a way other than using the derivative approach?
Ma'am, the minimum value of the entire function is 0. So that's why for n equal to -2,
So
this
the
will have
point
the
is
minimum value.
that your sum of squared errors, this function, because the value of this function is your 4 times n plus 2 squared. Now this is a square term, and squares are always positive, right? Squares are never
0
negative.
or positive.
4 is also right. So they're not negative. The squares are not negative. Your 4 is not negative. That means this entire thing is either greater than 0 or it's equal to 0, right? So the minimum value of this function, now if you have something like this, that means, so if you have a function greater than equals to 0, then the minimum value it can take is, actually what happens is your minimum value of fx should be is greater than 0. To prove for minimum value of fx equals to 0, what would we want? We'd want the 0 value to be attained in the sense that we'd want at least one x for which fx becomes 0. Then only we can say that the minimum value of fx is 0, right? If your function is always greater than equals to 0, this means that it can be 0 or it's greater than 0. So it's completely possible for the function to take only these values, to take values after 0 and not take the value 0, right? That means if it's given to you that 0 is greater than equals to fx, then it's possible that your function is, can I say that, okay, let's say you have 1, 2, 3, this is the list that you have. Can I say that every element in this list is greater than equals to 0?
Yes, ma'am.
So what this thing means is that your x can be greater than 0 or it can be equal to 0. It's not necessary for it to be either of the cases. It's not necessary for x. It's possible that your x is, now if you have something like this, 0 plus 0 set, and x belongs to this set, let's say, then also I can say that 0 is greater than equals to x. So what this means is x is greater than 0 or x is equals to 0. So one of these can happen. Both of them need not happen, right? So if your fx is this, that means for minimum of fx to be 0, you would want some point to exist x naught such that fx naught is 0, right? You want one point to attain that value at which the value becomes 0. Then only you can say that the minimum is 0. Otherwise, how can you say that it's 0? It could be always greater than 0, right? So similarly, if you have this thing, you would need one number, and in this case, it happens because it's a pretty simple function. So you can find n such that this big thing becomes 0, right? So
If we
and
-2.
right, this means this is 0, and this should mean that your n should be equal to
-2.
-2. So the minimum value should be attained at n equals to -2. And the minimum value attained is, what's the minimum value attained?
0.
Right. The minimum value attained is 0, and the minimum value is attained at, attain means at this point you get value 0. So at -2 you get 0.
-2 it is 0.
And if you want to do it the derivative by the derivative approach, you can do that too. You can find the derivative of this function and then equate it to 0. That
Or
will
you
give
can
you,
find by vertex of quadratic.
yeah, you can do that too. There are a lot of ways to do things. So by derivative, you'll have 8n plus 2. Okay, let's not do the derivative one because this will be 8n plus 2. And then you'll have to equate it to 0 to find the value of n. This will give you n equals to minus 2. Or you can do the vertex approach too. That is also going to give you n equals to minus 2. Is it clear to everyone? Can we move to the next question?
Yes.
Okay. So the next question is this one. Given that m, n, and p are the roots of this polynomial, and it's given that m plus n, because the sum of the roots is given to be 0, and m, n, and p are the roots, so the sum should be 0, right? And what else is given to you? You have to find. It's given that m, n, and p are roots of this equation. That means m, n, and p satisfy this equation, right? That means m cube plus 5m minus 10 should be equals to n cube plus 5n minus 10 should be equals to p cube plus 5n minus 10, and all of these values I have equated them is because all of them are 0. So all of these values are 0. And what do you have to find? You have to find the value of m cube plus n cube plus p cube. So what you can do is you can just add these three. If you'll add these three quantities, this one, and this one, you will get m cube plus n cube plus p cube plus 5m plus n plus p, right? Not doing anything, we're just equating this expression, we're just adding these expressions. This is first expression, this is second expression, and this is third expression. So we're just adding 1, 2, and 3. And when you'll add these things, you'll have 5 common, and m plus n plus p will be there, right? So this, and then minus 10 plus minus 10 plus minus 10 is minus 30 equals 0. Now you have to find this. You have been given this, where m plus n plus p is 0. So that means, is adding these three things clear? Or maybe I should have written these equations separately. Let's say this is 0, this is one equation, this is equals to 0, this is the second equation, and this is equal to 0, this is the third equation. Now you have three equations, and you have added those three equations. Left hand side of the three equations with the left hand sides, and the right hand sides are added, which gives you 0. Now you have to find this value, and this is given to be 0. This implies your m cube plus n cube plus p cube is will have minus 30 equals 0 here. That will mean the required value is 30, right? Is this clear to everyone? This was a
Yes.
pretty simple question. Is it fine with everyone?
Yes, ma'am.
Ma'am, can you explain this again?
Yes, ma'am.
Yes, ma'am.
You want me to repeat this thing?
Yes,
No,
ma'am.
ma'am.
So given that it's given that this is given to be the equation, right? Can you see the question?
Yes, ma'am.
Okay, so this is given to be the equation, and they say that m, n, and p are roots of this equation. That means if you put m in this equation, you should get 0, right? This is not even an equation right now. This is just a polynomial. So when you say that x, or you say a is a root of, or 3 is a root of px, that means your p3 is 0, right?
Yes, ma'am.
That means if you substitute m in this equation, not equation, in this polynomial, if you substitute m, n, and p in this polynomial, n you will get 0. If you substitute n, you will get 0, and at p also you will get 0. This should have been p here. This is n, and this should have been p. That means these are the three equations that you will get from substituting m, n, and p in this polynomial, right? And you have been given that the sum of the roots is 0, and these were the roots. That means the sum is 0. That means this thing. And what you have to find is m cube plus n cube plus p cube. So what we do is we just simply add these three equations, because we have to find m cube plus n cube plus p cube, which we can get by adding these three, right? M cube, n cube, p cube. So if I'll add these three equations, I'll have m cube plus n cube plus p cube from the first terms, right? Then from the second one, I'll have 5m plus 5n plus 5p. So this will give me 5. And in bracket, we have n plus n plus p. And then from here, you'll have minus 10 plus minus 10 plus minus 10 minus 30. So we've just simply added these equations. And it's given you have to find this value. This is to find. And this is with it's given to you, right? M plus n plus p is given to be 0. That means your m cube plus n cube plus p cube simply becomes 30. Is that okay?
Yes, ma'am. Thank you.
Now next is this question. Which of the following is correct with respect to polynomials? A polynomial is an algebraic expression, and we discussed this thing while we were discussing the theory, that if a polynomial is basically this thing, an expression that looks like this, a0 a1x, and it continues till ak x to the power k, and this k has to be a finite number. That means this has to end somewhere. It cannot keep going on. Finite natural number. Right. So what all is allowed here? This is an algebraic expression consisting of variables. There's a variable here, coefficients. These are coefficients, and non-negative integers, integer exponents. So exponents are these. The powers are called exponents, and these have to be These all have to be natural numbers, right? Because we're taking natural numbers here: x to the power 0, x to the power 1, x to the power 2. That means they all have to be non-negative integers. Non-negative integers means starting from 0 and then it keeps going on. Combined using addition. So you can use addition, you can use subtraction too, that's fine. And you can multiply, you can use multiplication. Multiplication in the sense if you multiply a0 x, and let's say we discussed this thing where we said that if we have x, then we have x to the power 4, x to the power 10. And multiplying these is going to give you, if these are different terms, multiplying these is just going to give you another polynomial, right? However, that's not the case with division. You can't divide things and then expect that it will still be a polynomial. So this option should be correct. Then coming to the second one, they're asking if this is a polynomial. So this is already a natural number. That's fine. It doesn't matter. This one does not matter because it's not the exponent of x. That's why it doesn't matter. In simple words, exponent of coefficients don't matter. Only exponents of these variables matter, right? And then here you will have the power x into 10 by 4, which is just 5. This will just be x to the power 5. That means this is just 5. This can be rewritten as 7x to the power 5 plus 5x cubed plus 2 to the power 0.5. And this can be, you can now compare it to this one. And you just have to check that the exponents of x are natural numbers, which is true here, right? Yes. This should be a polynomial. So this is a polynomial as well. Then if fx is equals to 0, is called the zero polynomial. Fx equals to 0 if you have a function, let's say fx equals to 0, then I can call this to be a polynomial, right? Fx can be a polynomials do not have equal to sign. So this is a polynomial if it's 0, right? It's the 0 polynomial. So if fx is 0, that means that fx is a 0 polynomial. And the degree of 0 polynomials is what? It's not defined, right?
Not
0 as a
defined.
polynomial is not defined. That means it's right.
Okay.
This is correct as well. Every 0 polynomial is a constant polynomial, but the converse is not true. So 0 polynomials in typical, they can't be called a constant polynomial because while this, okay, they can be actually, I was just confused about the terminology. So if you have a 0 polynomial, that's 0 is a constant, right? It's the same as that one only. 0 is a constant, but every constant is not 0, right? If you have 0, that's a constant, but not if I say that a is a constant, then a need not be 0, right? There could be non-zero constant. That's why this is correct. Then coming to this one. Now this one, I remember someone asking it in the previous classes, and I didn't think it
Yes,
back
ma'am.
then. This can be solved.
Session.
We have sufficient information on this question. So it says, we forgot the division algorithm, right? When you have a polynomial and it let's say gets divided by qx, then you can write it as qx hx plus rx. So if you have a polynomial and it's divided by x minus 1, that gives remainder 3. So that means if I'll have, or I don't even need the x minus 1 part, I can just simply, we have to find the remainder when px is divided by x minus 1 and x minus 2. That means when this is the divisor, right? So if x minus 1 and x minus 2 is the divisor, I can write it as x minus 1, x minus 2, and then some quotient hx, and then the remainder rx. And we have to find this remainder, right? So because this is, first thing is this is a quadratic thing. So okay, we'll come to that one. And what have you've been given? So if you have been given that on dividing by x minus 1, the remainder is given, and on dividing by x minus 2, the remainder is given, right? What's the remainder given? 3 and 5. This is given to you. First thing from here is, let's talk about the degree of Rx so that we can write it in its general form, right? Based on what kind of polynomial it is. Is it a quadratic polynomial or a cubic polynomial? What is it? So your degree of Rx should be less than the degree of divisor, strictly less than, and the degree of divisor is, the divisor here is x minus 1, x minus 2. So that means your degree of Rx should be strictly less than 2. Now that means your degree of Rx is, it's either 0 or 1, right? Or your Rx just be 0. So, or your Rx is 0. These are the possibilities. Either your degree of Rx is 0, or it's 1, or your remainder is just 0. These are the three possibilities that we have for now. And it's given that your x minus 1, when we divide this thing by x minus 1, remainder is 3. Now, by remainder theorem, we know that px, when divided by x minus 1, not the remainder theorem, actually the division algorithm only. Let's say the quotient is h1x and the remainder is r1x. So if I'll put 1 here, I'll get p1 equals, this entire thing becomes 0. So this is 0 plus r1, 1, right? and your remainder is 3. That means this remainder was just 3, right? We could have written 3 here because it's given that the remainder is 3. This will be 0 plus 3. This means that your P of 1 should be 3. Similarly, if you do it for x minus 2, so if you divide it by x minus 2, you'll have, let's say, some quotient h2x, and then the remainder. And remainder is 5, right? Now, if I'll put 2 here, why am I putting 2 here? Because on 2, this thing becomes 0. So this entire term becomes 0. So this is P2 equals 5. So your P2 is 5, P1 is 3, right? And then we have this thing where your remainder is Rx, where it could be, now let's just check it for 0. If your Rx is 0, then that would mean your Px is equals to x minus 1, x minus 2, and hx, right? If remainder is 0. And then if I'll put one here, I'll get P1, okay, I'll get P1 equals to 0, right? If I'll put 1 here, I'll put 1 minus 1, so this will become 0. So this entire term will become 0. That would mean that your P1 should be 0. That means value of P at 1 should be 0. But here we saw that the value of P at 1, this is the information given to you, should be 3. That means this should not be correct, right? That means your remainder should not be 0. So this is case 1. We have 3 cases, right? Your remainder can be 0, or the degree of remainder can be 0 or 1. So we'll test each of these cases. The first one is remainder being 0. Not possible. That means your remainder cannot be 0. So this case is rejected then. Next up, we have case 2, which says that your remainder's degree should be 0. That means your remainder is a constant, right? Some constant which is not equals to 0. This would mean, again, you will do the same thing here. You will have Px equals x minus 1, x minus 2, hx, and let's say the remainder is c, right? So you'll add c here. And this is going to give you, so if I'll put 1 here, then P1 will become c. And if I'll put 3 here, because the value at 3 is also given, right? 3 or 2? 2 is given. So if I'll put 2 here in P, I'll get P2 equals to C. Does anyone have a doubt till this part?
No, ma'am.
What we're doing is we have gotten 3 cases from the degree of Rx. The degree of Rx possible is 0, 1, or there's one more possibility, Rx is 0. So you now have 3 cases. You have to check which one of this is true, right? So we've already checked for Rx equals to 0. Why? Rx cannot be 0 because if your Rx is 0, then your Px looks like this, right? Because your Px was this. If you take R 0, then you will get this thing, this equation. And if you put 1 here in place of x, you'll get P1 equals to 1 minus 1. This gives you 0. But we already know from the information that's been given in the question that your P1 is 3. That means your remainder should not be 0. Then the second case is your remainder is the constant. Now, if you have your remainder as this constant, non-zero constant, this means non-zero constant. So you will have Px equals to x minus 1, and in place of remainder, there will be C, right? We have replaced Rx with C. Now, if you will put 1 here, you will get C. If you will put 2 in this equation, you will get C. That means the value of P1 and P2 should be same. But if you will have a look at this question, it's given that at P2 you have 5, at P1 you have 3, and these two numbers are different. Now, this is not possible again. That means you should not be taking something constant as remainder. So something constant, 0 or non-zero cannot be the remainder. This leaves us with the only possibility that your Rx is of degree 1. That means your Rx is Ax plus B. Now, if you will put Ax plus B here, you will have Px equals to x minus 1, x minus 2, hx plus Ax plus B. Right? This is the remainder. If you will put 1 here, you will have A plus B, right? Substitute 1 here and you will get A plus B. If you will put 2 here, this entire thing becomes 0 and this will be 2A plus B, right? This thing will be 2A plus B. So you will have 2A plus B. And P1 is given to be how much? P1 is 3, P2 is 5. It's given in the question, right? That means P1 is, this thing is 3, A plus B is 3, and this is 5. Now you have two equations. You just have to solve these two. Solving this gives you A plus B equals 3 and 2A plus B equals 5. So you can just subtract this one from this. You will get A equals 2. And if you will put 2 here, this will mean that your B should be 1. Is this okay?
Yes, ma'am.
So that means your Rx should be, it's Ax plus B, right? That means it's 2x plus 1. So this should be the remainder. So let's check the options. We have 2x plus 1 here. Is this okay? Is this question clear to everyone?
Yes, ma'am, it is clear.
Okay.
Could you
Then
please
let's,
summarize it?
what we've done is, we have Px and we are talking about the remainder that we get when we divide this thing by x minus 1 and x minus 2. So first thing is you write Px as this thing, right? And you have to find this Rx. So we try to start connecting things about Rx. The first thing is that its degree should be less than, strictly less than, not even equals to. It should be strictly less than the degree of this, right? This is your divisor. So its degree should be less than this. And then by that you get, what do you get? This degree is 2. So the degree of Rx could be, we have discussed this thing over and again, right? Over and over, that your degree of Rx, either, this is either, that means either this is true or the other condition that I'm going to write, that's true. This is strictly less than degree of the divisor, or what can happen is that your Rx is 0. So either your Rx is 0 or its degree is less than the divisor, less than that of the divisor. So that means by this you get that either the degree of Rx should be less than this. That means the possibility, this degree is 2. That means the possibility for degree of Rx is 1 and 0. So the possibility for degree is 0 and 1, or degree 0, 1, or Rx equals to 0. So these are the three possibilities for Rx, right? Now we're checking each of these possibilities. If x minus 1 divides Px and leaves the remainder 3, that means P1 is 3. That's your remainder theorem, right? If x minus a divides, we have used remainder theorem here. You don't have to remember the name, but it says that if your x minus a, you're dividing, so the remainder that you get, remainder on dividing Px by x minus a is Pa, right? So if you divide Px by x minus 1, the remainder should be P1. And if you divide it by x minus 2, the remainder should be P2. That means the value of P at 2 is 5. The value of P at 1 is 3 by remainder theorem, right? By this theorem that we discussed here. This one. So now you have P1, you have P2, and you have this thing. Now if I put 1 here, P1 here, and you have information about this, that either it's a linear function, that means ax plus b type, or because if its degree is 1, then it's linear, that means it's of the form ax plus b. If its degree is 0, that means it's constant. Or the third possibility is that this entire remainder is 0. Now if you'll substitute 1 here, you'll have this entire thing 0, right? And if your remainder is also 0, that means px was also 0. P1 is 0, right? Substitute 1 here. Instead of x, you will get P1 equals to 0 if your remainder is also 0. And P1 is given to be 3. That means your remainder cannot be 0. Now the next one is you will take remainder equals constant. If you will take it to be constant, then your P1 and P2. Substitute P1 here, you will get the same constant. Substitute P2 here, you will get the same constant as we did here. P1 will give you the same constant and P2 will give you the same constant. But P1 and that means P1 and P2 should have same values. Not possible because they have different values. And then we have the third one. All you're doing is just test each case. That means put your remainder equals to what is possible. There are 3 possibilities. Put it equal to what's possible and put 1 and 2 to check if it's consistent or not. What do you get? So if I put 1 here, I'll get a plus b equals 3. If I put 2 here, I'll get this equation. And then you can solve these 2 equations. Now what could have happened is, when you have 2 system of equations, it's possible for you to not have any solution, right? When you have 2 equations or more than 2 equations, it's possible for you to not have, in this case, it's possible to not have any solution. For example, let's say if instead of these 2 equations, if I have a plus b equals 1 and 2a plus 2b equals 3, then this does not have any solution, right? These two don't have solution. Why? Because if you'll multiply this entire equation with 2, you'll get 2a plus 2b equals 2. But this says 2a plus 2b equals 3. That means there are no 2 numbers that satisfy both these equations. That's also possible. Then is when your third case would get discarded. Then this is also not possible, right? But that's not the case here. You're getting solution for this system. That means everything is going fine. Is that okay?
Yes, ma'am.
So let's come to this one. This is the graph for the question. And then they're asking what could be the possible expressions or possible. These are not equations, so this word should not have been here.
Possible
But let's,
equation.
okay. So this, yeah, that's fine, but we're discussing about this particular word. It should not have been here because none of this is an equation. None of these is equation here. They're all expressions or polynomials. You can call these polynomials, not equations. So let's see which polynomial has this graph or can have this graph. So we see that at 2, you have multiplicity even, right? So at 2, you have even multiplicity. This is root. This is multiplicity. At 3, you have odd multiplicity. At 4, odd. And at 5, odd, right? So let's just first try to see which of these options. Or, okay, because there are so many options here, I should write the multiplicity as per the graphs. Instead of going by each of these options, I am taking the multiplicity from this and then match it with the multiplicity of these. So 2 is a root, 3 is a root, 4 is a root, and 5 is a root from here. All of these are roots and all of these are mentioned here. That means there's no problem there. Then the multiplicity of root 2 is even because it doesn't cross the x-axis, right? So if it doesn't cross the x-axis, doesn't cross x-axis, this means even multiplicity, or it looks like this. If it looks like this is x-axis, and if it goes like this or this. That means it touches the x-axis and then goes back. Then it's even multiplicity, and if it crosses the x-axis, this means odd multiplicity. And graphically it looks like this. If this is your x-axis and the root is this, then it should cross, or it should cross this way. So 2, because it doesn't cross, so it should have even multiplicity. 3, it crosses. What? We have a doubt. At 3, because it crosses the x-axis, it should be odd multiplicity. So the odd multiplicity meaning the multiplicity of root 3, x equal to 3, should be odd. Then the multiplicity of 4 should be odd because it's crossing again. And then the multiplicity of 5 should be odd because it's crossing again. So let's check which of these options is not consistent with this information, if there is any. It's possible that all of these are consistent. So 2 is even, that's fine. And rest are odd, that's fine. This one should be incorrect because here you have a multiplicity. This indicates that the multiplicity of 2 should be odd. But the information that we have from the graphs, the multiplicity of 2 should be even. That means this is incorrect. And all the others are possible from the conclusion that we've drawn so far. We'll have to look for other information, right? So let's see what is different in these factors. This is 5 minus x and x minus 5. That means it's about the sign here. So let's check the sign of both of these polynomials in this region here. Then x is between 4 and 5. Let's check the sign of these three polynomials, right? What should be the sign of this polynomial when x is between 4 and 5?
Negative.
Negative.
It's negative, right? Because the entire graph is lying on the negative side of y-axis, right? Between x equals to 4 and x equals to 5, your graph is lying on the negative side of y-axis. That means the y values here are negative. That means if it's a graph of this first option, then your first option, when you will substitute a value between x equals to 4 and x equals to 5. So if this is the graph of this first option, and if I substitute the value between 4 and 5, here x equals to, let's say if I substitute x equals to 4.5, then what should be the value of this graph at 4.5?
Negative.
Not, we don't need the exact value. Obviously, you can't find that, but it's negative, right?
Yes.
Ma'am,
It should be negative.
Ma'am, can we directly equate 5 minus x to 0 so that x is equal to 5 and that coordinate we can check?
But how would you know which one to eliminate from that information? If you will put x equals to 5, then all of these are 0.
No,
equating
that term so that is the solution or a 0 of the polynomial.
Yeah, all of these give you x equals to 0 as solution, and x equals to 0 indeed is x equals to 5 is a solution, and x equals to 5 indeed is a solution, right? You don't get any different or usable information from there.
Okay, ma'am.
Because that's, if you use x equals to 5, x equals to 5 is a 0 here as per this graph, right? Because at x equals to 5, the value of 5 is 0. That means as per this graph, x equals to 5 is a root. And as per all these equations, x plus 5 is a root. That means you can't eliminate any of these, right? What we're trying to do here is we're trying to eliminate these options to see which one of these is not consistent with the graph. Is that okay? So the first inconsistency that we noticed is that as per this graph, the multiplicity of root 2 should have been even because it bounces back here, this. But as per this second option, the multiplicity of 2 is odd. That's why the option B is not consistent with this graph. That's why it's out first. then we're looking at other options. You have 5 minus x here, and the other ones are x minus 5, x minus 5. So let's work around this 5 root. So that means when you will have a value here from 4 to 5, let's say if you will choose a point 4.5 here, then as per this graph, the value of your polynomial at 4.5 should be negative. This is the value at 4.5, right? 4.5 and f of 4.5. And f of 4.5 should be negative because here you have your f of 4.5 is here, right? And this is negative y-axis. That means this value should be negative. So this says that your value at 4.5 should be negative. But if you check for these ones. Let's check for first option. If I'll put 4.5 here. So if I'll put 4.5, so 4.5 minus 3 is positive. 4.5 minus 4 is positive. And 5 minus 4.5, so you will get positive again, right? That means, oh wait. Yeah, so we're getting positive, positive, and positive. And this is already positive because it's a square term. You don't have to check for even power terms because they're always positive no matter what you substitute x equals to, right? So that means this entire polynomial at 4.5, this first one. A option, when you substitute 4.5 in A option, you will get a positive value.
It is wrong
Yes.
option.
How do you check it? Does everyone know how to check if it's a positive value or a negative value?
You just put x.
You
Yes.
don't have to solve it entirely. If it's x minus 2 square and x minus 3 cube, if you have something like this, then at 4.5, if you have to check at 4.5, or let's say 2.5, if you have to check at 2.5, then because you just have to check the sign at 2.5, this factor is always positive, right? Because it's square. Or
Yes,
if it was 4, then also it's always positive. So you don't have to check for even power ones, only check for the odd ones. Let's say you have x minus 1 here as well. So if you put 2.5 here, 2.5 is greater than 1, so this will be positive. And 2.5 is less than 3, this is going to be negative. Negative to the power negative is negative only. That's why we have to check for odd powers, right? So this entire sign is going to be negative. That means your function should lie below the x-axis for x equals to 2.5 in the particular example that we just did, right? So for 4.5, this option says that your graph should lie above the x-axis because you're getting positive for this option. At x equals to 4.5, this gives you a positive number. But the graph says that it's negative. That means this option is incorrect as well. Now coming to these two. You can't eliminate any of these by this information that you've discovered. If you substitute 4.5, you're going to get both of these negatives. You can check it without even substituting because this is only the
But the
powers are changing here, right?
multiplicity, yes, ma'am.
Yeah, multiplicity is going to play a
That
role.
seems to be linear, means 1.
So the point here is that there's no point putting values here because if you put anything here, these factors are just same, and this is odd power. Here also you have odd power, there you have odd power. So if you put anything here, an x minus 3 expression is same. So you're going to get the same sign, right? If your x minus 3 is minus 2, then minus 2 cube and minus 2 to the power 1, both are negative. That's why the sign is not going to change for these two expressions at
Visual
any point.
inspection.
Yeah, so the only thing that's left to do is you're checking these roots. Just looking at the graph and then trying to identify. So now the difference between these two is that this has one is a quadratic factor. That means this. When you have a quadratic factor, it looks like this, right? And when you have a linear root as in, by linear root I mean this, x minus 2 with multiplicity 1. When you have multiplicity 1 of a root, it looks like this. It's almost a straight line. Not exactly a straight line, but it looks almost straight. And if you have 3 multiplicity, then it's like this. It's something like this. That means if at point A, if there's a 0, if this is point A, and you have a 0 at this point, with multiplicity 3, x minus a cube, then it should look like this. So if there is a polynomial and x minus a cube is one factor of that polynomial, then it should look like this. So the point is it's something like this. It's not straight line. That's the point. And here, if you see, you don't see anything like this. Do you
Option
see?
C negated.
Yeah. You don't see something like this here, right? Either it's completely curved, this thing, or it's going straight. This is going straight, this is going straight, and this is also going straight. So that's why you should not have a 0 with multiplicity 3. That means this should be incorrect. That's why we don't have this option correct. So we're only left with this one. Is this fine?
Yes, ma'am.
Can we move to the next question if no one has a doubt in this one?
Yes, ma'am. Please.
Okay, so the next question is this.
These are from
So you have what?
These are from extra practice assignment.
Yes, I think so.
Ma'am,
Yes.
could you please repeat option number 1?
I can't hear you. Okay, let's do this question. Does anyone have anything to say, to ask?
Yes, ma'am. Could you please repeat option number 1 of the previous question?
Option 1.
Yeah.
How
Then
this gets
5
eliminated.
minus
Right?
x.
Okay. So you have x minus 2, x minus 3, x minus 4, and 5 minus x. All of these powers are 1 and this one is 2, right? Now, if this is the correct equation or correct polynomial for this graph, then the value at, let's say you have, if you take 4.5 as a number, you can take any number between 4 and 5, but let's take 4.5 here. If you take, or you can take something after 5 too, but we're taking this one. So at 4.5, your value should be negative, right? As per if this is your function, this is the graph, and graph is what? It's a collection of x comma fx points, right? When you draw a graph of something, it's a collection of x points and the corresponding y coordinates at a fx, right? So if this is a point, if you take x equals to 4, so this point is, 1 second. So this point should be, this is 4 here, we have taken this here. So this is 4.5, right? This is 4.5, comma f of 4.5. This is it, right? Where 4.5, f 4.5 is this. The y coordinate of this vertex, this point, and this is 4.5 is the x coordinate here. This is x equals to 4.5. So if you'll test this function, that means at 4.5, at x equals to 4.5, your function's value should be negative because it lies on the negative side of y-axis. This is negative y, this is positive y, right? That means your f of 4.5 should be negative. So this thing, f of 4.5 is negative as per this graph. Now, if you look at this option, if I substitute 4.5 here, x equals to 4.5. Let's say this is y. So your y should be equal to what? You just have to check the sign of y. As per the graph, the sign of y should be negative. Let's just check as per this equation. So if you have 4.5 here, you'll have 4.5 minus 2. Now this is a square term. If you want to check, you can check. but your squares are always positive. That means this is always positive. X minus 2 squared is always positive, even if you don't substitute anything. Then you substitute 4.5 here, 4.5 minus 3. 4.5 minus 3 is a positive number, right? You don't have to find that number. You can just see 4.5 is greater than 3. Then 4.5 minus 4. This is again a positive number. And then you have 5 minus of 4.5, right? So this is again a positive number. This means your y at 4.5 should be a positive number, right? Product of all positives, it's positive. But your graph says it should be negative. That's why this option is eliminated. Is that okay? Is this clear?
Between options C, that also seems to be
Yes,
a
ma'am.
because C is seems to be bit valid because x minus 4 has odd multiplicity, both of them, also x minus 3. And if we can check the graph, we can see a drag when x is 4, then slightly a drag. So
So there it should look, if you will see, if they have to ask you some, if it was x minus 4 cube, then you will clearly see something like that at something that if this is 0.4, then you will see something like this or something like this. You will see this thing there. It will be it will be clearly visible to you that it's of the cubic form. And this looks straight. Drag does not matter. Obviously, it's not going to be a straight line suddenly, because if it's a polynomial, we've already studied that they are you can't have sharp corners, right? So you can't have something like this. You can't have a straight line here. You can only have this, and then it can look a straight line around this. If this is the point, then very close to this point, it can look like a straight line, right? That's my point. It should look like a straight line here. It looks like a straight line here. Looks like a straight line here. Don't check the entire thing. Just check in the proximity of this point, in very close proximity of this point. They're all straight, like, right? Is it fine? Is there still a confusion in what we discussed about this third option being incorrect?
oh, no confusion.
Then we have this one. This question says that you have two spheres and the radius, there are two more spheres. The total volume, and the volume is 4 by 3 pi r cube. If r is your radius, then this is the volume of sphere. So that means if you take volume of A, volume A has radius x, right? So let's first get the entire equation correct. So sphere of A and sphere of B. There are two more spheres C and D, each of radius x. The total volume of A and B, the total volume of A and volume of B is y cubic units more than the total volume of C and D. So this is y plus y cubics more than, this means y volume of C, volume of D, and you should add y to it. So this should be the equation, right? And then you just have to find each of these volumes. So volume of sphere of A, the radius is x. That means this volume is going to be as per this formula. So if the radius is r, you have 4 by 3 pi r cube. If it's x, then the volume should be 4 by 3 pi x cube, right? Because it's given that the radius is x. Here the radius is 2x plus 1. So volume of B should be equals to 2x plus 1 cube pi 4 by 3. Then volume of D, so each of them has a radius x. That means their volume is going to be same, right? The only variable is r, and it's same for both of these x. That means this volume should be 4 by 3 pi x cube. Now we'll substitute these values here. So we'll get 4 by 3 and 2 times, because 4 by 3 is going to be common, so let's not multiply things here. We'll have 2 pi x square, not this actually, plus 1. We've just added the volume of this and this. Volume of A plus volume of B. And
Volume of
we have
A.
taken,
Okay. A and D will get cancelled if we equate.
yeah, they'll get cancelled, but firstly here we should have a square. But
It
let's
will
just
get
first write the equation. So this is 4 by 3 pi common, and this is x. Okay, we have a cube in both places. This is cube here and cube here. So we've added both of these. Volume of A plus volume of B gives you this. And then you have volume Y plus volume of C, which is 4 by 3 pi, and x cube 2 times, right? You have 4 by 3 x cube plus 4 by 3 pi x cube. So they just get clubbed together, and this gives you 4 by 3 pi common and 2x cube, right? This is it. So your y will be equal to, if you, that's what we have to do, right? Find y in terms of x. So y in terms of x is keep y on this side, take everything else on the other side. So you'll have this thing, 4 by 3 pi is common in both of these terms. So you'll have 4 by 3 common, x cube plus 2x plus 1 cube, and you'll have a negative here. So this is 2x cube. This is going to give you 4 by 3 pi, and this is 2x plus 1 cube minus x cube equals y. And what is y in terms of? Okay, we have everything expanded. Right. So finding the cube of this, so the cube formula is this actually. If you have a plus b cube, it's a cube plus b cube plus 3ab square and 3a square b. So that means you will have 4 by 3 pi, and then 2x cube is 8x cube plus 1 cube is 1. Then 3 times 2x squared and 1, and 3 times 2x and 1 squared. 1 squared is just 1. This will give you 4 by 3 pi, 8x cube plus 1 plus 4 p 12 x squared plus 6x. So one of these is matching 8. We need to have 8 here, right? So this one's matching, right? 8, 12, 6, and 1. 8, 12, 6, and 1. So this should be the area. This should be the correct option. Is this fine?
yes, ma'am.
Can we move to the next question? This is the next one. If this form is given to you, then what's the,
It
if
is
you have y
vertex form
minus y naught, yeah, vertex form, and
1 and 4.
a x minus x naught square, and that means your vertex is x naught comma y naught. Now you have this form here, y minus y naught and x minus x naught. That means your vertex should be basically what's subtracted from x. So 1 is subtracted, and what's subtracted from y? 4 is subtracted, so it should be 1 comma 4. The vertex is 1 comma 4. You can do it the minus b by 2a way too, but it's going to take time, especially in this case. So we're avoiding that method. And then the distance of this point from origin, from 0, 0 is 0 minus 1 squared plus 0 minus 4 squared and then square root, right? This is distance from origin. Of vertex from origin.
70.
This gives
Correct.
you
So,
root 70. That means this should be correct. And the parabola is symmetric about the line x equals to 1. So if you have a parabola symmetric about line x equals to a means if you have, let's say, this as parabola and this, the axis of symmetry, if it's x equals to a, then we say that this is axis of symmetry being x equals to a means when you fold about this line, it should be this part of the parabola and this part of the parabola should overlap when you fold about this line. And this is and the vertex is basically the point of intersection of this quadratic function and this line x equals to a. That's your vertex, right? So the parabola is symmetric about the line x equals to 1. So the x coordinate on this line, this is the axis of symmetry. That is what you've been asked in the second option. Axis of symmetry is x equals to a, and the x coordinate on your axis of symmetry is what? On axis of symmetry is a, right? Because the entire line is x equals to a. That means on this line, where a is changing, if you will move, if at this point y is different, this point y is different, y coordinate is different, but at all of these points on x equals to a, where x is constant a, right? So your axis, the x coordinate on the axis of symmetry is x equals to a. And what's the x? This should be the same as, because your vertex also lies on the axis of symmetry. This is vertex,
X
and
coordinate
it
of
lies
vertex.
on vertex lies on your axis of symmetry for the quadratic function. So your vertex, this should be equal to x coordinate of the vertex, right? And what's the x coordinate of the vertex? We have the vertex here, which is 1 and 4. So the x coordinate on the axis of symmetry should be equal to x equals to 1, right? Meaning your axis of symmetry is x equals to 1. The parabola is symmetric about the line x equals to 1 should be correct. Then we have the third option. The y-intercept of this parabola is 5. So you have to find the y-intercept. What do? You put x equals to 0, right? So if I'll put x equals to 0 in this equation, I'll get this thing. For y-intercept, we have y minus 4 equals x minus 1 squared. So if I'll put x equals to 0, I'll get y minus 4 equals minus 1 squared. So that's 1. This means y-intercept is equals to 5. And I think that's what the option says. So this should be correct. And coming to the D option, this is for A option. This is for B option. This one's for C. And the D option is about the parabola is a function which has two unreal roots. So we have to check if the parabola is, let's just sketch the graph of this, right? So if your vertex is 1, 4, so it's here. 1 here, 4 units here. And it's like this. And because your leading coefficient means the coefficient of x square. The coefficient of x square will be 1.
Positive means
So it's
open,
positive.
upward.
Upward.
Means it's going to open. So it's going to cut your y-axis. This is 1, 4, right? And this height is here. What's this height?
This is positive y, so
4.
That's positive, but it's also 0, 4 point,
0,
right? So the height is 4.
yes.
That means your y-intercept should lie above 4. If it's somewhat here, that means that option is incorrect. If the
Yes.
option says that it should be 3, then it should be incorrect. This says that it has 2. Parabola is a function. Okay, we don't need that. But I remember seeing some questions like this where you have been given the option as y-intercept. Let's say, can y-intercept be 3? Then the y-intercept can't be 3 because your vertex is at 4. It's opening upwards, so it has to be more than 4. So 3 cannot be correct. However, that's not one of the options here. The parabola is a function which has 2 unreal roots. So for the roots of a parabola, a parabolic equation, you have to find where it cuts the x-axis, right? And it does not cut the x-axis at all because it's going upwards. It cannot take values less than 4, right? That means it's never going to intersect the x-axis. Or in other words, it is never going to be, if this is fx, then fx can never be less than 4, right? Or in other words, in particular, you can just say fx can never be 0, right? That means if your fx is never 0, by never 0, we mean for real numbers. No such, or no real solution exists. When we say that this cannot be less than this, we mean no real solution exists, or here also we mean no real solution exists. And our option says that the parabola is a function which has 2 unreal roots, which is true. Because that's what we figured out, right? It doesn't cut the x-axis. That means, okay, so if your parabola cuts the x-axis at one point, that means it has repeated roots, right? Repeated real roots. If it cuts at 2 points, then it has 2 distinct real roots. And if it does not cut the x-axis at all, like this one or this one, these parabolas don't touch the x-axis, right? That means no real roots. Because the parabola that we have is of this form, the third category. That means this option is correct as well. Is this fine? Can we move to the next question?
Yes, ma'am.
Okay, so our next question is this one. Integral values means you only have to find the integer solutions of this, integer values of it, such that this equation has. So you have been given one equation, this equation, and you want the roots. This is a quadratic equation, right? Treat m as an arbitrary constant. So this is a function, or you can say a quadratic function in x, where x is the variable, m is some constant only. And so this is a quadratic function in x, right? Quadratic function in x means quadratic function in variable x. And if you want to have real roots, what's the condition that
D
we should
should
go by?
be D should be greater than equal to 0.
Right. The discriminant should be greater than equals to 0. That means, and your discriminant is this thing, b square minus
Square
4a.
minus 4 is.
You want this thing to be greater than 0 or equals to 0. And this says it has no real root. So you want the value of m such that there are no real roots. So for no real roots, you want the discriminant to be what
Strictly
should
less
be
than
Negative.
right. It should be
X
because
square
for
minus
real
4
roots
is
equal to is
less
included
than
here.
0.
It should not be equal to 0. This is strictly less than 0. So you want this condition, right? We're talking about no real roots. That means we want this condition to be true. What is b in this equation? B is minus 2 times 1 plus 3m, right? Your a is 1 plus m square and c is 1 plus 8m. So if we'll do b square minus 4ac, we'll have 4, 1 plus 3m squared minus 4 times 1 plus m square, 1 plus 8m. And we want this thing to be strictly less than 0. Now that means, let's take 4 common from here. Then you will be left with 1 plus 3m squared and minus 1 plus m squared, 1 plus 8m. It's nothing else that we can take common. So we'll have to solve this thing. So if we'll solve this, this is going to be 9m squared plus 6m plus 1. This one, expansion of this. And then minus the expansion of this because this entire thing is in negative. So you should have 1 plus 8m plus m square plus 8m cube. And we want this thing to be less than 0. We have 4 here. So since we have minus 8m cube, then you'll have minus m square and plus 9m square. That will be minus 8m square. Then we'll have 6m minus 8m. So this will be minus 2m. And 1 is going to get cancelled, right? So this is what we're going to have. Right? And we have a 4 here. Just once again, 9m and 8m. 8m negative and 9m and m square is, we should have a positive sign here, right? Minus m square and 9m square. So you should have a positive 8m square here. And 6m and minus 8m. Negative 2m. Right. This is fine. This should be less than 0. Now if this is less than 0, I can multiply both sides by 1 by 4. And we know that when we multiply an inequality, we've discussed this before. And if I multiply this with a positive k, so if I do ka, kb, this is going to be the inequality if k is greater than 0, right? That means if you multiply with something positive, then the inequality this is the inequality, doesn't change, right? So if I multiply this side and this side, both sides by 1 by 4, 1 by 4 is positive, I'll get minus 8m cube plus 8m square minus 2m less than 0. In a similar way, I can take 8 common from here, or maybe minus 8. So I'll have m cube, not minus 8. Let's take minus 2. So I'll have 4m cube minus 4m square and plus m. We have this thing here less than 0. And now because I'm multiplying by minus half. So I'm doing into minus half. And because I'm doing into minus half on both sides, that means the inequality, this should change, right? So this becomes 4m cubed minus 4m squared plus m greater than 0, right? This means I can take m common. I'll have 4m squared minus 4m plus 1. Okay, this should be greater than 0. And this is, I think, this is a square, a perfect square, right? This is m, so 2m minus 1, a perfect square of 2m, yeah, 2m minus 1 square. And this is m. If you don't want to do it this way, we can, if you can't see that this is the square of this thing, we can do it in an alternative way. But let's first do it this way. So if you have this thing greater than 0, and this is a square, right? That means you want to find values. So we've started from here. We want m such that d is less than 0. That means we want m such that this is true, such that this is true. And then we've just solved this entire thing, right? So we want m such that this thing is true. That means, and this thing is always, this is always greater than 0, right? Because this is a square term, so it's always greater than 0. That means we just need to figure out that m should be greater than 0, right? Or there's one more way, because you have this strictly greater than 0. You can't even take this. We want things to be strictly greater than 0. So that means we want m to be strictly greater than 0. Is this okay?
Yes, ma'am.
Now this would mean, because we're only allowed to take integral values of m. That means, so this says m should be greater than 0, and your question says, so as per question, your m should be an integer, and if you will take the intersection, that means this should be 2, this should be 2. That means if we write it in intervals, we'll have, in set form, this will be, that means your m should belong to 0, 0 is not included. So
Natural numbers minus 0.
0 to infinity, intersection, integers, right? This will give you natural numbers set minus the number 0. That means except 0, every natural number, m could be any natural number. M should be a natural number except 0. Or if you don't want to make this into a square term, what you can do is, an alternative way is, you have m 4m square minus 4m plus 1 greater than 0. Then you can do these two things. You can have the roots of this. Then you'll have to find the roots. The root is going to be, because the factor was 2m minus 1. If you find the root, you'll get m equals to half. And only m equals to half, that means you'll have two roots. M equals to half, let's say m equals to half is here. Now, if you look at this quadratic equation, half is one of the solutions, m equals to 0 is other solution of this equation, of this one, not equation of this function. If this is a function in m, then half is one of the roots of this function, one of the zeros of this function. M equal to 0 is also one of the solutions. And this is, then you can just, because at m you have this, either it's going this way or it's going this way. and you can put the values there. You can put the value less than 0. So if you substitute m less than 0, let's say you're doing m equals to -1, m less than 0, you will have this as negative, and if you put -1 here, you'll have 4, -1 squared is just 1, so -4, minus plus 4, and plus 1. So this is giving you a positive number, right?
Yes, ma'am. Ma'am, the stress factor positive, so and it's a odd degree polynomial, so as it extends to minus infinity, the f of x will also tends to minus infinity.
No, actually, we're not using the, if you're saying that this is, if in case you're saying that m is the stress, and we don't already know that m is positive. We're trying to do it the alternative way.
Okay, ma'am.
Let's
But
say you have this condition. Yeah.
I'm talking about the stress factor, the coefficient of m, that is 4, which is positive. The coefficient of highest degree of m.
Right. This one's also fine, but okay, what's your question?
Ma'am, what I'm saying is, here the coefficient of highest degree of m is positive, and
Okay.
and it is a cubic polynomial. So as x tends to minus infinity,
Yeah, you can
so
do that too.
yes, ma'am, in
That's
that
also
way,
right. You'll have 4m cube, and then if you take x m tending to infinity, you'll have this entire thing going to infinity. So it will
minus.
be this here, and if you take minus infinity, it will be this here. At 0, you should have this thing. That's also fine. You can do it this way as well. At m equals to -1, you're getting fm negative. So that means this should be negative before 0. And then because it's just one thing linear, so odd degree, odd
Yes, ma'am.
multiplicity actually. M has odd multiplicity, so it should cross this way and then it should go this way.
Then it should touch the 1/2 because we have
Yeah, this is m
even
minus half.
whole
Yeah,
square.
half has even multiplicity, so it should go this way. And these are the only two, I guess. This will be a graph. And what was the question? The question was about m. You wanted this entire thing to be positive, right? So you have to find m such that this entire thing is positive. And if you look at the graph, now this is the graph of this thing. And after, so you have to find this is here you're taking m, and here you're taking fm. Fm on y-axis, m on x-axis. That means you have to find the value of m such that your function is positive, which is m greater than 0. You can do it graphically too. Is this okay with everyone? Can we move to the next question?
Yes, ma'am, please.
Okay, this one is the next question. So, been given a polynomial function, and you have to, so for you to be able to answer these options, you first have to plot a rough sketch of this. So let's say this is plotted here. This is 0 point, let's say, and so your roots are 1, 2, 3, 4. From here we're finding the roots, and then on the negative side you have -1 and -2. Starting with, you have a negative thing here. We can consider it to be k and then some polynomial where k is negative. That just makes things easier because 0.01 is of no use. Only the negative sign is of use here. Let's start
Can we
with this.
determine the n behavior first, just to
Is the end
make
behavior
this.
for this. -2. So we'll start from this side. You can start from either of the ends. You can start from this end or this end, your choice. We're starting with this end. So if you have x tending to, because you're at 2, the multiplicity is even. That means either it's going to be this way or it's going to be this way. But we have to figure out which one of them is true. So one thing you can do is you can substitute something immediately here. You can substitute something left to -2 and check the sign of this function. You can do that. The other thing that you can do is you can check the end term behavior of this function. So by end term, what you do is you'll find when x tends to -infinity, where does your px go? So if your x tends to -infinity, this one goes to -infinity, this one goes to -infinity, this one goes to, sorry, this is even powers, right? These two are even powers, so they are going to +infinity. This will go to +infinity, this will go to, as x tends to -infinity, -infinity -1 also goes to -infinity. And because we have an even power here, that's why this factor goes to +infinity, this one goes to +infinity. This again goes to -infinity, this one too to -infinity, -infinity. And this one again, because it has a positive power, an even power, that's why this goes to +infinity. So if you combine all these signs, and you have a negative here, right? Negative of 0.01. So negative, negative, these two become positive. Then you have negative here, these two become positive, and you're left with one negative, right? That means when your x tends to -infinity, this function should go to -infinity. That means this behavior, when x tends to -infinity is here. As you keep going to the left side, this function should go to -infinity. That means it's like this. So this possibility gets eliminated, right? Because in this possibility, your px goes to +infinity as x goes to -infinity. That's why this is not possible.
X tends to infinity, then also px tends to minus infinity.
Right? If you've checked for +infinity, similarly, you can check this thing for +infinity by substituting, not substituting exactly, but if you take +infinity in place of x, and then by checking signs, you can see that the final sign you'll get for +infinity will be -infinity. That means this goes to -infinity. So from this end and from this end, these go to -infinity. And then you have a root here and a root here, right? So at -2, because the degree is even, that means you should have this, right?
Yes, ma'am.
Then obviously it doesn't matter if it's like this or if it's just like this, because we're not sure about the turning points. So let's just draw one turning point, right? For now, let's just draw one. There could be more turning points here, right? We're not aware of that right now. So you'll have this thing. And then at -1 is this one. -1 is this factor. And its multiplicity is 1. That means odd multiplicity. So it will cross this 1, right? Then at 0 also you have a root. That means it will have to take a turn here to meet 0, right? If it's going upwards, it will have to turn to go to 0, to intersect the x-axis at 0. So this will be it. And at 0, the 0 root factor is this one, right? And it has multiplicity 1, x to the power 1. This is x minus 0 to the power 1, right? That means at 0, this should cross again, odd multiplicity. Then it will take a turn again. And at 1, the degree is again odd. So it should cross this one, right? And then to meet 2, it will have to come back down. It can't keep going up. And then at 2, you have multiplicity 2. So even multiplicity, so it should be like this. Then to meet 3, to cut the x-axis at 3, it will have to again turn here, take a turn, and then meet 3 here. And then the multiplicity, the root corresponding to this root 3, your factor is this, right? And it has multiplicity 2. That means, so for even multiplicity, it's this. For odd multiplicities, it's this, right? That means that
Yes.
3, you have even multiplicity, it should go like this. And then it will need to take a turn to meet at 4. X-axis at 4. And then we cross this. So this is, so far it's been consistent, right?
Yes,
Now
ma'am.
let's say we're not sure if one of these could be like this, right? That we're not sure of yet because we've not counted the turning points. But for now, let's just take this. And even if it's something like this, it's not going to make any difference, at least for the first option. The first option says that your px is 1 function when x belongs to minus infinity to 2. So minus infinity to 2 is this one. This one. And 4 to infinity is this one. This entire thing after 4. So everything
Yes.
after 4 and everything before minus 2. Now if you look at these two, it's not 1 here, right? Because this one is also going to infinity. This one is also
It
going to
is.
infinity. And at y,
For
okay,
that,
at two different, yeah, what?
particularly for that area, -2 to minus infinity, it's 1 to 1.
We're talking about the union, right?
Oh, acha.
It's for the, yes, you're right. If you will take minus infinity to minus 2, just this one, then your graph is like this, right? You have minus 2 here and minus infinity here, and it's going down. Then obviously it's 1, 1 here. Because at every point, for different x, you have different values of no two values of x give you same value of y. That's why this is 1, 1, or it passes the horizontal line test in one word, right? But if you have minus 2, this, and the union is taken with 4 and infinity, this interval, then you have 4 here, and after 4 it goes like this. So obviously, if you will do the vertical line test, it crosses,
2
it
points.
cuts this graph at 2 points. That means it's not 1, 1 here. Not 1, 1 in this interval. When could it have been 1, 1 though? If one of your branches here was like this. Let's say if this was going to plus infinity, as x goes to plus infinity, then this will be 1, 1, right?
Yes, ma'am.
This is 1, 1 in minus infinity to minus 2, union 4 to infinity. But the one that we have, not 1, 1, in minus 4, in minus infinity to minus 2, and then this one, 4 to infinity. So your first option should be incorrect. And coming to the second one, the total number of turning points is 9. Let's just first look at the degree of this. The degree is 1 from here, 2 from here, so it's 3, and 2 from here, 5, 6, 7, 8, 9, 10. The degree of this polynomial is 10. And then the total number of turning points will be, so we know that the maximum number of turning points, one
N
second.
minus 1.
Yeah. So the maximum number of turning points your px can have, if the degree of px is the degree, maximum number of turning points for px is less than or equals to degree of px minus 1, right? Or you can say the number of turning points instead of maximum. So number of turning points for 1 second. Yeah, so this should be it. And then let's just, so that means the maximum number of turning points this can have is 9. So let's count the number of turning points that this graph has. This might not be the exact graph of this, as we've discussed that this could be this, right? Or in any other places, this could be possible, right? This same can happen here or here or here. We're not sure yet because we've not used any information to find these things, turning points. So let's count the number. So the number of turning points is either these or more than these, right? So this is 1, this is second turning point, third, fourth, fifth, sixth, seventh, eighth, ninth. So we already have 9 turning points. Now, if I do this thing, I said that this could be a possibility, but now it's not a possibility. Why? Because if I do this thing, I'll have 10 turning points. But the maximum number of turning points I can have is 9. Similarly, I can't have something like that in other parts as well. I can't take this as this. Because then we'll have 8 turning points and 9, 10, 11, 12, 13. There'll be a lot of turning points, right? Whereas we can only have 9 turning points. Maximum 9 turning points. It could be less than 9, but not more than that. That means this should be how it is. And this says the total number of turning points of Px is 9. Now, why is it 9? This is true because as per the graph that we have drawn for C, no, for B, for the rough sketch we have drawn, number of turning points should be greater than or equal, should be less than or equals to 9. Sorry, should be greater than or equals to 9, right? Because 9 we've already seen. Now, what was our hypothesis? That it could be that you have something like this. That would increase the number of points. So the minimum number of points is 9 as per this graph. And it can have more than that number of turning points. More than 9 number of turning points. And then as per this rule, the number of turning points of Px is less than degree of Px was 10. So it should be less than equals to 9, right? 10 minus 1, 9. That means the number of turning points is exactly 9.
Since this is polynomial of degree 10, so will it have at most 10 roots?
The roots are 10, but the turning points are the roots of derivatives.
Turning point.
Right? So it can have, counting multiplicity, it does have 10 roots. So this is multiplicity 2, right? If you count from here, this is multiplicity 2. So that means 2 is repeated 2 times. 2, 2. Then 1 is 1 time. 3, 3, 3. Then 4, 0, 1, and 2. Minus 2 and minus 1. So these are the roots. So that means the total number of roots now is 9. If you count them, these are 10. 10 in number. Total roots are 10, counting multiplicity. So if you count the multiplicity, it will be 10. If without multiplicity, it's obviously not 10. There are just 1, 2, 3, 4, 5, 6, 7 roots without counting the multiplicity. Is that okay?
Yeah.
Okay. So, and then we have the third option, which is Px is greater than 0 when x belongs to minus 1 to 0. This one, 1 to 2, this one, 2 to 3, this one, and 3 to 4, this one, which is true. So Px is strictly greater than 0 when your x is in these intervals, in this interval or this one or this one or this one. That means this is also correct. And then there are exactly 9 points on Px where the slope of the tangent is 0. So your slope of tangent is, you will see later, but it's not the case here. If you have something like this, then the slope of tangent here is considered. Now this is not a turning point. If this is x cubed, then x equals to 0, not a turning point. not a turning point. But slope there is 0, right? Slope 0 basically means if you have this point, we say, and this is a function, let's say. So slope 0 means if I'll take x equals to this point, so at this point on this curve, this will be the corresponding point here, right? If I draw a straight line just touching this at one point, at this point, it will be parallel to x-axis. So that's what slope being 0 means. So if you'll have something like this, then your slope should be 0 here, right? And your slope should be 0 here, slope should be 0 here, because all of these are parallel to x-axis. If you draw this one, this is a turning point. If you draw a straight line that cuts this thing and only cuts it at one point, that's your tangent, right? This is the tangent, and this tangent to this point is parallel to x-axis. That means at this point the slope is 0. So we say that if this is your curve, so at this point the slope is at this point. Let's say this is x0. So I draw this point here. I see this point here on this plane. And then I draw a tangent line here. Or you can say a line that touches this curve only at this point. I draw a straight line here. And then let's say this is theta angle that it makes with it. So tan theta is basically the slope of this curve at this point. And that's and tan theta is your tan theta is the slope. Now if you have something like this at this point, let's say if you're doing it at this point x1, then the tangent would be this, right? This straight line which is parallel to x-axis. So if you will see this, the angle between this line and this line is actually 0. So tan of theta will be 0. In simple words, because I don't want to get into slopes and all, if you have the tangent at one point, let's say this is your point x equals to x1. If your tangent is this, which touches the graph at that point at x equals to x1, and it just touches it at that point. So this is your tangent. If this tangent is parallel to x-axis, then you say that your slope is 0, right? So if you have where the slope of the tangent is 0, so you'll only have slope 0 at these points, at the turning points, right? Why only at turning points, at these points, and not at other points? There are no other points where the slope is 0. Because you don't have something like this. You don't have your curve going like this. So you don't have to worry about slope being 0 here. Is this okay? So there are exactly 9 points in this case. This is correct. I think we're done with the questions for today. If no one has any doubt, then we can end this session here. Do we have any doubts?
Ma'am, can you please explain the first point once again?
The first option?
Yes, yes.
Your graph, you are clear with how we draw this graph, right?
Yes, ma'am.
Now it doesn't matter. I am emphasizing on these things that it is pretty possible because how we've drawn this graph, it's possible for us to have this thing.
So we can use one more thing because degree is even, so we can simply check the end behavior. A is less than 0, degree is 10, so obviously the graph would be downwards, right? The end behaviors will show downwards.
Yeah, that's what we've done. We found the endpoint behavior. This one, end term behavior. When x tends to minus infinity, your px tends to minus infinity. And when x tends to plus infinity, your px tends to minus infinity. That's what we've done.
Yeah, I know, but you have
And if
chosen the
you're,
different
yeah,
method. You have put the minus
yeah,
infinity plus infinity.
I
You have picked
understood the
that way,
point.
and as I know, because the degree is even and the const a is less than 0, then obviously the behaviors will show downwards, right?
Yeah, this is an even degree polynomial. So your leading term is this minus
Yeah.
0.01 to the and x to the power 10. So you can use this term to find the end term value.
Yes,
That's
yes.
also fine.
Yeah. Okay. Okay. Thank you.
You're clear. Someone had a doubt in option 1. Are
Yes,
you clear
ma'am.
with how we plot the graph?
Yes, ma'am. Got it.
This
Thank you.
is, you've understood the option already, or should I
Yes, I understand.
elaborate on it? Okay. So are there any other doubts?
Yeah. No, it's clear.
I think we can end this session here. So all the best for your quiz 1.
Thank you. Good night.
Right.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.